Welcome back, everyone. Today we're going to be starting a new lesson in the next level module. This is called Autodesk Inventor Solid Modeling Exercises under the caster. And we're going to be starting with the valve body today. So we're going to click into this and take a look at it for a few minutes. Let's just reorient this properly. Alright, so this one is a bit different because you're actually already looking at the fully dimensioned orthographic drawing view, and you're going to have to create an isometric 3D model of this part. Now, there's a lot going on here, so we need to kind of study it before we get started. Now, it does recommend here, I wrote hint, use point and hole feature. Now that's specifically for right here in the top view. So creating this drilled hole and these 4 tapped holes. Because these holes are not drilled all the way through. They're only going to be drilled up to a certain depth. So when you drill a hole into a piece of metal, you're going to have a drill point left behind. And we need to include that drill point to show a true representation of the manufacturing process when building this part. And also with the threaded holes. When you thread a hole, if anyone's ever taken manufacturing class, you have to drill a hole first. It's called a tap drill size, and then you thread after the fact up to a certain depth. So it's very difficult to see in this top view because the end is kind of cut off by these drilled holes that drill right from top to bottom. And the other thing we're going to have to do is use a work plane to create this extrusion that's cut in the middle here. And we have to make sure we don't make a mistake that we don't dimension this incorrectly. Because it's showing a dimension from the top of this front extrusion as 1 inch to the center, but we also have to account for this little lip here that sits higher, that's 0.100. So we're using a work plane to create this extrusion as well. We're going to be extruding in with a plane towards the main body. So to get started, I recommend that you start by making a sketch of the base first, including this flat milled section at the rear, and its dimension from the center of the base to the flat part edge, that flat edge at the back, that's showing as 1.38. And also the base radius circle is dimensioned as R1.75. So I've got enough information to kind of get me started here, so I'm going to get started with this, and we're going to click on to Inventor. So this will be the last time I show this in my video. And I want to make sure that I'm under templates English. The units are imperial. We're going to use standard inch IPT. And we're going to hit create. Alright, so to get started, 2D sketch. Today I'm going to start with the XZ plane. Not that it really matters, but I want to build this from the base up, right? So I'm picking a plane that was already sitting flat. So I'm going to start with a circle. It's very, very important we start on X, Y, 0 because a lot of the dimensions are coming from the origin on Inventor's 2D sketch plane. So we're going to start with a circle. We're going to dimension this to be 1.75. Now this is a radius, but it's showing as a diameter. So I need to multiply this by 2. Asterisk 2, check mark. Alright, so it's a 3.5 inch diameter circle. Next, we're going to create the milled edge at the rear. So I'm just going to use a line. I'm just going to sketch a line horizontally like this. And then use my dimension tool and go from the line to the origin. This is going to constrain to 1.38. Check mark. Next thing I'm going to do is go to modify, get the trim. I'm going to trim the access part of the radius and these access lines on each side. So there's my base fully constrained. Finish sketch. Extrude. This is going to extrude, according to my iPad PDF image here, the base is 0.40 thick. And check mark. All right, so here we go. I got the base. We're off to a good start. Next, we're going to build the main body of the valve body, which is the central extrusion. There's a lot of holes that are going to be passing through this. So we're going to use another 2D sketch, and this time I'm going to select the top face of the base, which is fine, but I'm going to use a rectangle this time. So I'm just going to sketch a rectangle roughly like this, and then begin to constrain it. So this is a width of 2 inches. So I need to dimension from 0, 0 origin to each side 1 inch. And then from each side of it, so the entire length of it is 3.25 according to the top view. So we need to divide this by 2 to make sure it's centered, right? So we're going to click dimension, go to the origin, we're going to type 3.25, and we're going to go \2 because we have to divide it over 2 sides. Check mark, and then repeat on this side. 3.25 divided by 2. Now, before I extrude it, I want to add the fillets in 2D sketch mode first. So fillet is here, and according to the sheet, the fillets are radius 0.5. So we'll update this and go around and create the fillets in 2D sketch mode. Alright, so those are done. Hit finish sketch and extrude. And we're extruding all the way to the top now. And it shows from the bottom all the way up to the top is 3.65. Now, before I hit OK, I have to subtract the base because the way it's dimensioned on the sheet, it's showing the overall height from very bottom to very top. I've already extruded the base, so I need to subtract the base away. So minus 0.4, hit OK, and here we go. We've got it. Okay, so we got our base, we've got our main body. We're going to continue from the top now. And this, because these holes are going from top all the way through, I'm just going to use the circle feature because I don't need to show any drill points at this stage. So I'm going to draw a circle to 0, 0. This one is dimensioned as 1.25 diameter. Check mark. Select circle. Line up these and keep going. All right, the value of these holes, according to the sheet, they are 0.5 as well, same as the radius. And they are dimensioned from center point to center point. The image on my iPad tells me it's 1 inch. So we have to divide that over 2. So from the origin, let's undo that. Try that again. This is 0.5. And lastly, these holes are dimensioned 1.25 from the center. There's just nothing like a fully constrained sketch, is there? Finished sketch. We're going to extrude all these at one time. We're going to go extrude. We're going to select all these profiles. We're going to go cut, and we're going to select extents to be all. Hit OK. All right, so we've got those holes complete. They pass all the way through the base. And what we can work on next is we can do two things. We could work on the blind extrusion in the body, or we could work on the front extrusion that extrudes towards the body. So I think what I'm going to do is I'm going to work with the extrusion that's blind inside the body. So to get started with this, I have to use a work plane. So I'm going to select the plane, pull it down. And don't get fooled here. I mean, some people may offset this as 1 inch and think that that's correct because that's what it shows on the front view. But that's from the front extrusion that we haven't created yet. So we have to account for that little offset. That front face sits 100,000ths of an inch below the very top. So I need to actually add a 1 here. This should be extruded -1.100 to be correct. Now we're going to hit check mark, and we're going to hit 2D sketch, and we're going to sketch on the work plane. I'm going to create another circle, snap it to 0, 0, and I'm going to make sure I don't sketch it to be larger than this extruded hole, because if I pull it off too much, I'm not going to be able to see it anymore, because the sketch is sitting inside an extruded feature. I can still touch it, but I'd rather be able to see it still. So I'm going to hit dimension, select it, and we're going to set this. Now this is dimensioned to a hidden circle on the top view, which, as you know, is one of my big no-nos. No, right? But that's the way it is on the sheet. 1.75. We're going to have to fix this up on our drawing file. And hit the check mark. Okay, so now here it is. I can still touch it, right? I can't see it, but if I flash my cursor, it highlights. Let's hit finish sketch. Hit extrude. And it already picks it up. It wants to create a boss extrusion. What we want is a cut. But we want this to be symmetric. We want it to extrude in both directions at the same time. So we're going to hit the symmetric. Again, this needs to be adjusted. The extrusion is 0.25 per side, and it also gives the overall of 0.5. So we can just type 0.5. It will symmetrically extrude at 0.25 each direction for us. Making sure cut is selected and OK. All right, so it's there. We really can't see it, but it's there. We will get a better view of it when we complete this model. And in a future exercise, I'm going to show you how to slice the graphics so you can actually get a sectional view temporarily in a 3D model. But I'm not going to show you that today because I'm going to save that for when it's actually required of us to be able to finish a model. Right now, we don't need to kind of get into the inside of this to keep working, but in the future, we've got a model that we need to cut into temporarily to be able to complete the inside of it. So we're getting into some more advanced modeling procedures in this course. All right, the work plane can now be hidden. We don't want to delete it. Right click, unclick visibility. All right, so we're kind of getting near the end here, but we still got quite a bit of work to do. We're going to create a work plane from this face and offset it outward. So we're going to hit plane, select this face, and we're going to pull the plane out. Now, how far are we going to pull it out? Now the front extrusion that we're going to create, its front face is directly in line with the front quadrant of the base radius. So I need to know what the radius of the base is. And I do know what that is because it's listed as 1.75. But one thing that I have to think about here is I'm not pulling, I just can't type 1.75 and call it a day because it's going to be too far, right? If I orbit this, that's not correct. I need this to be in line with the front quadrant of the base. So I have to look at how this thing is dimensioned. The base sits, the front of the base this feature right here is dimensioned from the center of that hole to here. That dimension is worth 1 inch. So what I need to do is subtract that from my offset, and that's going to bring it where it needs to be. So this needs to sit really 3/4 of an inch off of this face to this front of the curve here. All right, and this, where do I get this information? I'm just examining the valve body iPad image in front of me. You have to kind of study this drawing quite a bit. And it's my hope that you don't just copy these videos, that these videos are good to be watched once or twice, but you really need to make these drawings on your own to be able to fully understand how to do this stuff. Again, not very many people do, but some will just copy my videos, and then when it comes to do a test, they're up the creek without a paddle. So something to think about. All right, so I'm going to hit the check mark. Let's take a look at it. Looks like that plane is sitting exactly where it needs to be. So the math works out. So what are we going to do now? We're going to create a sketch on work plane number 2. 2D sketch, select the plane, and we're going to be building this very much like we built the main body extrusion. So we're going to start with a rectangle. It probably doesn't need to be that big, but oh well. We're going to hit dimension. And the first thing I would do is dimension it by looking at the drawing. I would work top to bottom, how it's dimensioned. I know by looking at the right side sectional view that this sits 100 thou from the very top. So I'm going to start by selecting this edge, this line, and modifying that to be 0.1. And I know by looking at the front view that from here to here is 2 inches. And the overall length of this is 3 again, like the top view, 3.25 divided by 2. So I can use this to help me. This is like a little center point here. So I'll select this line here and here, and then type 3.25 divided by 2. That'll bring that right in line with the right side of the main body, and then a repeat on the left side. 3.25 divided by 2. Why should I try to figure it out in my head if I don't need to? Inventor is great for that. Now, so there's a sketch on the work plane ready to go. Now, at this stage, I would not extrude this quite yet. There are fillets here, like I did here. this may cause a modeling error trying to add the fillets after it's extruded. So you could try it, but I have a feeling it might give you a modeling error. And we get into the harder parts. If you're doing things in a funny way, an inventor doesn't like it, it will give you modeling errors. So we're trying to avoid that. Everything I've done so far has been perfect. So I'm going to go back into Sketch 5 here. I'm going to go back into Edit Sketch. So right click as I exit it out. Go into, and just before I continue, remember, if you ever exit a sketch, to get back in, you go to Sketch, right click, left click, Edit, and you're back in. So a little review there from grade 11. We'll hit Fillet. It's already set for 0.5. It's the same fillet value for the body. We'll go around and we'll create these fillets in 2D. Okay, now we're ready to extrude it. Finish sketch, extrude. We want to go the other way. We're doing a join, and then we're going to be selecting an extents to next. And it's going to stop the extrusion whenever it hits any type of surface, no matter flat or curved. So perfect. Look how nicely that wants to extrude it. It's basically the right side of this extrusion and the body are seamlessly joined as one. And it would be the same on the left. So we're going to hit OK. And look at that. Wonderful. The work plane. Again, take the visibility away because we don't need it anymore. But why would we get rid of it? We need to keep a record of how we're creating these parts in our project browser. So we have a couple of things left to do. We have to add the threaded holes and the hole here in the center. So why don't we do the threaded holes first? 2D sketch, select this face. This time we're going to use the points. So we're not using circles because circles are going to be too hard and it's going to be more work. So if we use the point, we'll just randomly drop some points, try to line them up, and we'll constrain them. So again, like before, these are going to be dimensioned. They're 1 inch from each other. And they're 1.13 from the center. And now they just need to be set on our Y value here. So if from here to here is 1 inch and from here to here is shown as 2 inches, then we know that it's going to be ½ inch. So we're going to go from here 0.5 0.5. Now what do we have here? Let's check. All right, so everything is centered the way it needs to be. This is going to over constrain the sketch. Right, everything is purple. All right, so this is all even numbers. So now we're going to hit Finish Sketch, and we're going to select the hole feature. All right, so it remembers, yours may not jump like this, but we're just going to set the parameters. So right now it's set for simple hole. We're going to change this to tapped hole because this is going to give us the threads. Now it says on the iPad image that we're doing 4 holes. There's 7/16-14. So 14 is threads per inch. So we're in unified, ANSI unified screw threads. We're going to have to change the diameter. Now 7/16. What is 7/16 in a decimal form? So if you were to take 7 divided by 16 in your calculator, you're going to get 0.4375. So this is the decimal equivalent. We're going to select it. And it says right here in designation 7/16-14. And what it doesn't say on the iPad image is UNC. So this stands for Unified National Coarse Thread. Right? You typically have national coarse, national fine threads. These threads in the Inventor model are going to be what I call fake threads. They're not going to be something real. It's basically just a graphic that it's going to add into the model and the drawing file. So we're actually going to sketch our own real threads when we get into more advanced features. So we have to set the termination here. So it's going to do a thread depth automatically of 8.875. You know, it should default to this, and we can leave that alone. But the full length here, this needs to be adjusted, and it says that we're going 1.25 in depth. So we're going to change this to 1.250, and we're going to hit OK. And this is what I'm talking about. So it shows the threads, but again, they're just graphics. They're not real. So it's basically just simple threads, and it's really all you need. But anyway, we'll dive deeper into threads another day. A couple more things to do. We've got the large hole here. So we have to do this one separately. 2D sketch on this face. One last point. Again, this is dimension 3.25 divided by 2. And this is going to be 1 inch. From the top of the extrusion. Finish sketch. Hole. We're going to switch from thread to simple hole. And we need to make sure that this is set, that termination is set for a distance. We're not going all the way through. We're not going to another surface. So make sure distance is chosen here on termination. So the diameter is 1.25. So that's what I'm showing right here. And also the depth is to be adjusted to be 1 inch. And we're going to hit OK. Now we're going to see how we did. Let's take a look at this. So this is what I should see. This is pretty much a duplication of the valve body as seen on the iPad image sheet from the hub. Right, there's my extrusion that I created earlier, and there in this oval shape that's equal on top and bottom is the drill point angle that's left, because some of it got eaten up in this extrusion I created earlier. Right, so this is how this should look. This is perfect. It also says that. And before I continue, I'm just gonna save this now here, and I don't want to put this in Caster, so I'm just gonna create a new file for these. But I'm gonna call this valve body. I'm gonna have an IPT of it, And there's fillets that you can add. It says at the top, unless otherwise specified, all fillets and rounds are 100 thou. So you can hit the fillet, change this to 100, and you can go around and create these fillets. So we can free orbit this up. So there would be a fillet there and there. And there would be a fillet at the bottom here. And hit OK. And that is it. So that is your valve body. So a little bit of critical thinking involved in this, but part looks great. Again, it reminds me of a pneumatic block, actually. Something that I did in industry a long time ago. I worked on something very similar for a pneumatic hydraulic company. But anyway, that is how you do it. If you were having difficulty with this, I hope this video serves you well. And I'd like you to complete the valve body, and we'll talk soon. Take care for now. Bye-bye.